Hello, my dear children. Today we are going to discuss about the concepts or points in exercise 1.5 in the chapter sets. Okay, my dear children. These are the points. These are the concepts we discuss today. First one, complement of a set. What is meant by complement of a set? What is the definition of complement of a set? And second one, Venn diagrams. Venn diagrams related to complement of set. And the third one, some properties of complement sets. Okay, my dear children, we discuss these concepts today. Are you ready to listen the class? Yes. Now come to the definition of complement of a set. Let U be the universal set and a subset of universal set. We have taken capital letter U is an universal set and a set is a subset of universal set. Then complement of A is the set of all elements of universal set which are not the element of A. This is the definition of complement of set A. Symbolically, we write A dash, A dash or A power C, A complement. Both are denoting the same, the complement of the set A. To denote the complement of A with respect to universal set. Thus, A dash or A complement is equal to set of all x such that x belongs to universal set and x does not belong to A. This is the set builder form of A complement or A dash. Obviously, A complement A dash is equal to A complement is equal to universal set minus A. We use this formula to find complement of the set A. Okay, my dear children, let us take an example to understand this definition clearly. Okay, my dear children, right. For example, universal set U is equal to set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the elements of the universal set and A is equal to set 1, 3, 5, 7, 9. These are the elements of the set A. Then A complement or A dash. A dash or A complement is equal to, this is the formula to find complement of the set A or A dash. Okay, my dear children, is equal to, that means difference of these two sets. You have already learnt about the difference of two sets. We use that knowledge here. Okay, my dear children, right. First we write here universal set minus here set A. After writing the sets, what I said, in finding the difference of two sets, we have to strike out, we have to cancel the common elements. So first of all, we have to identify which are the elements common to the both sets. Here one is element common, here one. So strike out 1. And here 3 is also common element. Here 5 is a common element and 7 common element and 9 common element. So we have to strike out the common elements in the both sets. After striking out the common elements, we have to write the elements in the set brackets, the elements which are left in the first set. What are the elements left in the first set? 2, 4, 6, 8, 10. These are the elements left in the first set. Again I told you we should not consider the elements which are left in the second set after cancellation. Okay, my dear children. So this is a complement or a dash. Understood, my dear children? Right. Now come to the Venn diagram of complement of a set. See here, this is a universal set. We have drawn a rectangle to denote universal set, and its subset A is denoted by this circle. Then the complement of set A is shaded by this slant lines. So this portion, the shaded region, that shaded portion denotes a complement. A complement or A dash. So A dash or A complement is equal to this slant lines shaded region. That is slant lines shaded portion. Understood, my dear children? Right. Now come to the next point, third point, some properties of complement sets. Okay, my dear children, these are the properties of complement sets. First one, complement laws. Here A union A dash is equal to universal set, and A intersection A dash is equal to phi. These two are said to be complement laws. Okay, my dear children. Next, De Morgan's law. De Morgan's law. First one, A union B whole dash is equal to A dash intersection B dash. Here I represented A union B whole dash by the means of Venn diagram. See here, I have taken the universal set. In this universal set, A and B are two subsets. Then A union B whole complement means we have to ignore the portion of A union B in the universal set. The remaining portion of the universal set should be shaded. So this horizontal lines shaded region denotes A union B whole complement. Here A complement intersection B complement. See here, here also I have taken universal set, and A and B are two sets. A complement I have shaded with horizontal lines, and B complement, here A complement, here A complement is denoted by horizontal lines, and B complement is denoted by vertical lines. B complement is denoted by vertical lines. The combined portion is nothing but this portion. If you observe in these two diagrams, the shaded region is same. The shaded regions are same. That is why we can say that A union B whole dash is equal to A dash intersection B dash. Okay, my dear children? Right. Now come to next De Morgan laws. A intersection B whole complement is equal to A complement union B complement. I have represented A intersection B whole complement by the means of Venn diagram here, and A complement union B complement I represented that set by the means of Venn diagram here. See here, A intersection B here, this part. Except this part, we have to shade the universal set, the remaining portion of the universal set. So I have shaded by horizontal lines. This horizontal lines shaded portion, or the horizontal lines shaded region, denotes A intersection B whole complement. Now come to this Venn diagram. In this Venn diagram, A complement is shaded by these horizontal lines, and B complement is also shaded by these horizontal lines, because we are finding union of these two sets. So we have to use the same kind of lines in the both sets. Then we get here A complement union B complement is equal to this horizontal lines shaded region. If you observe these two Venn diagrams, the shaded portions denote the same. That is why we say that A intersection B whole dash is equal to A dash union B dash. This is one of the De Morgan laws. And next one, law of double complement. Law of double complement. That is A complement whole complement is equal to A, or A dash whole dash is equal to A. This is called law of double complement. And next one, laws of empty set and universal set. Pi complement or pi dash is equal to, you get universal set, and u dash universal set complement is equal to phi. Okay, my dear children, these are some properties of complement sets. Is it clear, my dear children? Right. Now the concepts of exercise 1.5 was over. Now come to the exercise 1.5 sums. See page number 20. Page number 20. Question number 1. Question number 1. Let universal set is equal to set 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the elements of the universal set. And set A is equal to 1, 2, 3, 4. And B is equal to set 2, 4, 6, 8. And C is equal to set 3, 4, 5, 6. These are the given sets. Now we have to find A complement. Second question, B complement. Third question, A union C whole complement. Fourth question, A union B whole complement. Fifth question, A complement whole complement. And sixth question, B minus C whole complement. Okay, my dear children. Now come to the first question, A complement. How do you find the A complement? What is the formula to find A complement? Universal set minus A. That is the formula for finding A complement. So universal set minus A. So I wrote here universal set minus set A. Now we have to recollect the previous knowledge of difference of two sets. How to find difference of two sets? What should we do? We have to identify the elements which are common to the both sets. After identifying them, we have to strike out them. We have to cancel. So 1, 2, 3, 4 are the common elements in both sets. So we cancelled here. We strike it out. Then what are the elements left in the first set? 5, 6, 7, 8, 9. So this is the required set. Understood, my dear children? Right. This is A complement. Now come to A union C whole complement. I did not complete second question. You try the second question. You find B complement. Can you do it, no, my dear children? Right. So I am doing here third question, that is A union C whole complement. So without finding A union C, we can't find directly A union C whole complement. That is why first we are finding A union C. A set A 1, 2, 3, 4. Union set C 3, 4, 5, 6. Now we are finding union of these two sets. You know how to find union of two sets by combining all the elements. So 1, 2, 3, 4, 5, 6. This is A union C. Now come to the actual question. A union C whole complement is equal to universal set minus A union C. In the place of A, here A union C is there. In that formula, we are substituting A union C in that formula, A complement formula. So universal set minus A union C. So you have written universal set minus we have found A union C. We wrote that set also. Here also we strike out. We cancel the common elements in the both sets. After cancellation, what are the elements left in the first set? 7, 8, 9. This is the required set A union C whole complement. Understood, my dear children? Right.